Okay, we got the wheels all back over here now. I went and dug out the case race to put in a case over there. Looks like we're doing new bushings and a cam cover, new crank pin and new pinion shaft. So that means we're going to reuse the sprocket shaft. I need to check the fit of that, so we'll keep that open. This here, there's some new bushings in here, so I got to grab those, which I don't have out right now. So we got check, and we got the heads here. These were rebuilt by somebody else. They put seats in here already. I'm not supposed to make comments about the quality workmanship. They told me not to tell them what I thought about stuff. These ports are horrible. That's what I think of them. What a crappy casting that is, huh? They didn't knock any of the high spots off in here to make it breathe better. So if you knock it off right there, that'll pick up about 15% of airflow right there, just knocking that edge off. Yeah. Probably one on this side too. Nope, this one's all undercut. That one's bad. Too small. Too big on that side. Too small here. Knock that way. Right there. Gain some power. And the intake. Knock out some of this crap in here. And gain some power too. I don't know if I'm supposed to port this or not. These pretty bad castings. What a core shift. Yeah. The loops over there. Normal. And of course, that's real centered up on exhaust, which doesn't really matter too much on that. It's going to go through that hole. So it's a lot of work cutting that out, but it can be cut. That's pretty thin there. Hopefully it doesn't break. That happens. Alright, so I don't know. You don't know if he wants to put those or not. So these are the valve springs. Unknown quality. Definitely not the way I do things with collars. I think I was going to swap this stuff out as a recall. Yeah. Nice and tight there, huh? Jeez. You have to worry about them sticking. Intake's a lot better. Still loose, but better. Okay, that's not too bad. The intake's not bad. Exhaust, pretty loose. Alright, I'm going to go ahead and pull this other head apart here and see what I got to play with. See how bad this thing really is. So other people don't do things how I do it, so I can't pick on everybody. Well, I could, but it's redundant after a while. Unless it's really bad, I'll just keep it to myself. How's that? Yeah, it's probably not going to happen either, right? Oh, I got these crappy valve seals in there. Oh, the ones that have no clearance for lift. See how the spring takes the seal right off because it's hitting on it? What ain't happens when the spring goes up and down? Yeah. So you cut the collar away to make room for the seal. So the collar is no longer sitting on top of the guide like it's supposed to. It's sitting on top of the head. See, they cut the whole collar out. Put a big ass shim under here, which means they have to sink the head way down. The head's not made to do that. Valve don't feel too bad. Yep. And they cut into the head to make it a flat spot down there. See, that's not how it's supposed to be. Yep. It'll work, kind of, until the seal falls off, like it just did. It doesn't work too good. There's always more than one way of doing things. Turn an exhaust port. It's always nice. Keeper didn't want to fall out of there. Must have, I don't see it no more. It's in there somewhere. Nope. Keeper's not in there. It's the seal hitting on the spring again. Yeah. Yeah, seal's not supposed to go up and down with the spring. That is not how they're supposed to be. Yeah, nice and tight. Doesn't come out. Not a good sign. So take a socket, push the seal out. It didn't want to come out. That one appears to be a little tighter. Bring out the old hammer for this one. Still not coming out. Ah, there it goes. And got my thumb. My sore thumb that hurts like hell right here, I just hit with the hammer right there, which makes it feel even better. Yeah, it really hurts now. Yep. It feels like there's a knife stuck in between the joint right now. Yep. Thank you. I like that. Yep. Yeah, the pain goes away eventually. Okay, let's see what they got for clearances on this thing. Doesn't take much to put that on there. Okay, this is the reason why this crap doesn't work like this. Okay, we got to figure out how bad this really is. Everything's covered with grease. You don't need to grease up your keepers. They don't need to be lubricated. You don't need to have grease to hold them together either, if you know what the hell you're doing. Okay, so here's one greasy collar. We got to determine how far the keeper sits away from the groove here. See how the keeper is below the notch there in the valve. Keeper groove. So you got to put the collar in here. And let's see how that fits up. So you can see how the keeper sticks through the collar a little bit. They do line up nicely. That's good. At least they match. I like that part. Okay. So the keeper is what's going to hit the seal. So it's a lot easier to check this stuff. So you just take one keeper, lay it on top of the valve right there. The valve is pushed all the way against the seat right here on this side. So the clearance right now is, we got this seals all the way against the top of the guide there. So you measure between the keeper and the guide, I mean the top of that seal, and that's how much lift you can run max. So at 325 thousandths, if even that, the retainer is going to hit the seal. Now, I don't want to burst your bubble, but these motors have more than 325 thousandths lift. They have more like 390 maybe, 385, 390-ish. So that means you have a 1/16 of an inch of interference with that seal against that keeper. Now the seal will not like that, it's going to break. Now do you see how the seal is broken right here? That's because it doesn't like to be nailed by the valve when it opens. Because basically this collar just jams right into that seal. Seals do not work when they get jammed like that. The other problem that happens is rockers like to break because they do not like being hit like that and bottomed out. That's why I do not use these seals that come in the gasket sets. They're these nice automotive seals that are great for sealing and all that, but they're too damn tall to use in a Harley. They don't fit. So what I use is I come over here. And I get the sportster valve seals. See, I have those same seals right here, see? I don't use them on these applications. Okay, this is the K-line seal. The first thing you're going to notice is it's a lot shorter than that seal. That means you just gained a 1/16 of an inch of clearance. We needed that 1/16 just to make it 0. The next thing is, see this guide here? You can shorten that guide up quite a bit to get all the way down further. Not all the way that deep, because there has to be a collar in there, but we can go down probably that deep, right there. So we cut about a 32nd to 50th thou off the top of that valve guide pretty easily, and we gain it. So you go down to 400 thou on these pretty easy on these collars, these top of these guides. And right now this guide is about 470 thou. So you can cut 70 thou. There's a 1/16 there, a 1/16 there. We just gained an 1/8 of an inch. An 1/8 of an inch on top of 325. That'll be 450 thousand clearance. That gives you just enough to clear a set of Y cams at 425 lift, and have 25 thou clearance for the oil to not be forced in, just by putting the correct parts in there. Now that's not using this piece. This is junk. It also, this does not fit inside the spring, whereas that one does. See? Look at that. No problem. Goes right in and out. Doesn't hit on it. See, it fits. This one here, bottoms out. Doesn't fit. That's the first clue. It doesn't work there. It don't even fit inside the spring. So that's why I don't like using crap that comes in gasket sets. Use this old stuff that don't work very well, because it works. Now the other thing is I don't cut collars like that. That is stupid. I cut my collars like that. I think it's not cut around here. Okay, most valve collars have an upper lip right there. What I do is I cut that lip off, because that makes room for a seal. That means the seal, instead of hitting way up here like that, can hit all the way down there, which gains you more clearance. So, when you put this thing on top of your head, see now the collars, or the lower collar, sit on top of the guide, which helps hold the guide on the head. It also gives you clearance between the head and the retainer, so now you're not transferring all that heat into your spring, because springs don't like heat. So that makes everything better. And you still got the clearance you needed. So there you go, that's how I do it. This here doesn't work very well. The other problem is it gives you a nice cup basically to collect oil, so if this does seep in oil through it, it sucks a nice wet oil flow right into it. That's another problem. So we're going to wind up using some stock collars probably. Okay, next thing is what kind of a spring tension do we have here? So this is an upper. Yeah, look at all the. Make sure we're beating on those things a lot to get them out of there. Oh, there's a whole set right there. Look at that. Okay, I'm gonna check that. I'm gonna grab my one I just put away over here. Make sure this fits. Obviously, it fits on that. Gonna make sure that fits on there. Yes. Okay, so boom, bam, boom. Okay, there's two sets. The spring tester. Can't afford a fancy one. You use one of these cheapy ones like this. Puriform. It's probably, you know, $100 part, as opposed to a couple $1,000 professional spring tester. This works just as well. Okay, so we come over here to our press, otherwise known as our spring testing machine. This costs more than a couple $1,000 though. Some of you want to know what kind of press I got. That type. There you go. You have to watch the video to find out what that is. Okay, first thing we're going to do is take their spring, or their collar, and set up. And let's see what kind of tension we got. It'd be nice to have about 85 or 90 on the seat. Over 300 open would be really nice, but I doubt if we'll get it. Maybe. Let's see, we're about 350-ish. Oh, I just opened. There, that's where coil binding is. See, the little hit drops real quick and this kind of slows down. That's where the spring comes back in. Okay, so the outer coil is not the one that's binding. Let me do my scale. Did I grab my scale? Yep, I did. What the hell is binding? It's obviously not the outer. It's got to be the inner, but yeah. So the inner spring is what's binding. So if you want more coil bind clearance, cut the inner spring height. That means you cut the height of this down a little bit, or you can cut the one up here down a little bit. That'll gain you clearance. Okay, so there's about 90 pounds. Each of these are around one. Let's see here. These are about 1/300 on some of these things. What's this one at? We're at 275-ish. So this is going to be under 90 pounds, but not too bad. These are probably kibble white springs, would be my guess. Which means they're a decent spring, but somebody butchered the collar. Okay. So now we're going to put the Harley collar in here. Let's see what we get this time. Oop. Okay, now we're a little bit more tension, we're about 380. Looks like we coil bind on the outside of the spring now, which means we got more coil bind clearance probably. I didn't measure that, we'll measure that next. So that means we got more room for more lift. So this is working the spring equally. Okay, let's drop this down to about 90 pounds again. Somewhere about there. Let's see what our number is right here. Okay. 1/300. So this has a little bit more tension. It looks like maybe an extra 5 pounds with this combination. And I bet you we have a lot more coil bind clearance. So that means the next thing we're going to check is our coil bind clearance. So when you don't know what you have to do all these measurements to figure things out. Of course, if I do the heads, nobody will remember what I just did.